All right, welcome to the screencast for scientific measurement. This is going to cover objectives 5, 6, 7, and 9. We're actually going to skip number 8 and we will come back to it. So objective number 5 is list the SI units of measurement. So what are our standards that we have to record everything to? That's what this is going to focus on. So when we look at our standards, our System International, this is the standard measurement system used everywhere in the world. You have to realize that the U.S. and a couple of other countries don't use the metric system, but all the scientific fields do. So medical, biological, chemical, physical, etc. We will use the metric system in a science classroom. Just because the U.S. As a whole doesn't mean that we won't use it in the science classroom. So you're going to have to learn how to convert between metric system units as well as metric and English units. And we wouldn't have to do the English units if the United States would just get on board with everybody else, but we still do. So that's part of the dimensional analysis that we'll talk about later. But trust me, the metric system is much easier. So what are the standards in measurement? Results are reported universally to these units. So if I take a length, the universal standard to report it to is meter with the symbol M. Mass is kilogram. Temperature is in Kelvin, not Celsius or Fahrenheit, but Kelvin. Time is in seconds. Amount is in moles. We're going to talk about what a mole is later. And electric current is in amps. Oh, the last one, luminous intensity, is how bright something is. That is in candelas, which you can actually see that measurement still used today, even though we tend to use watts more commonly. But these are just the standards that you would have to report something to in the metric system. And volume, meter cubed. A lot of times we take a volume in milliliters, but 1 milliliter is equal to 1 centimeter cubed as far as that conversion goes, and then you would just convert centimeters cubed to meter cubed. That is the standard to report volume. So objective number 6, identify various units for length, mass, and volume measurements. So length is going to be the distance between two locations. You measure length with a ruler, a meter stick, a yardstick. Common units might be meters, miles, kilometers, feet, inches, centimeters, or yards. So length is just how far apart two things are. Volume is the amount of space that a substance or object occupies, measured with a graduated cylinder, beakers, or rulers if it's a regular shaped object, because remember you can take length times width times height to find the volume of something. Common units would be liters, milliliters, centimeters cubed if you're doing length times width times height, gallons, quarts, ounces, tablespoons, teaspoons, cups. Those are all common units for volume, which is the amount of space that a substance occupies. Mass is actually how much matter is in that object. So it's how many atoms are in it. You measure it with a balance, a scale, a triple beam balance. Some common units would be kilogram, gram, milligram, pound, or ounce. Would be some common units for mass, which you remember is how much matter is actually in that object. So we're going to do this activity in class. You guys are going to take measurements of a variety of different things, and you're going to practice length, volume, and mass measurements just to make sure everybody can do them. Objective number 7, just a real quick refresher on the difference between mass and weight. Mass is defined as the amount of matter in the body, so it's actually how many atoms there are. It is a fixed quantity. Your mass is not going to change no matter where you are in the universe. So it is independent of location. No matter where you are in the universe, your mass is the same. It's the same as your weight on Earth. Weight, however, is a measure of Earth's gravitational force on the body. So you stand on a scale, and it's how much gravity is pulling down on that spring that's in that scale. And that's what tells you the weight. That's what correlates to the weight. So it is not a fixed quantity because it's based on gravity. So it's dependent on location. If I change the gravity, I'm going to change your weight. So it changes as gravity changes. You're going to weigh less on the moon because there's less gravity. And I know there's some typos on here. You're going to weigh less on the moon because there is just less gravity, but it doesn't mean that you're losing actual mass. You're not losing any matter. So we're going to watch this video clip in class. You do not have to watch it right now. Okay, I'm going to skip objective number 8. And I'm going to click to objective number 9, as this is the last objective for the screencast. After your measurement activity in class, what we're going to work on is dimensional analysis problems. So we are going to actually do the setup for dimensional analysis. We'll do some practice problems in class together, and then I'm gonna turn you guys loose to do more practice problems for dimensional analysis. So this is just a problem-solving method. It's a method that allows you to convert from one unit to another. And in order to do that, you have to have conversion factors. I'm going to give you a table of conversion factors, as well as the metric system conversion chart. But I'm going to give you a table of conversion factors so you will not have to memorize these. Some of the basic math principles, and I will review these with you. You multiply across the top, you divide by the bottom. So if a number's on the top, you're going to multiply by it. If it's on the bottom, you divide by it, just like any kind of standard math problem. You're going to report your answer to the correct sig figs. And another piece of information to remember is that conversion factors do not count towards your total sig figs. So there's some steps to dimensional analysis. You first want to identify what unit you're starting with and identify what unit you're ending with, and then see, do I have a conversion factor that'll get me from point A to point B? From there, you set up your railroad tracks or your T-boxes, which is what I tend to call them. You'll write your answer down, or you'll get your whole setup, you'll solve your problem, write your answer, and then determine your sig figs in your final answer. So here's kind of some diagrams of the setup. You always want to put in this is why I call it a T-box, because it does look like a T, but it's also sometimes called railroad tracks. You're going to put what you have, what you're starting with, the number and the unit, and you are going to plug in a conversion factor here to get you from what you have to what you want to have, or what you need. So from point A to point B. And if you put something on the bottom, that cancels it out. So you're going to divide by it. And if you put something across the top, you're going to multiply by it. So this line means to multiply, this line means to divide. Just pretend this is a parenthesis. If you have two numbers next to each other in parentheses, you multiply them. And when you divide, remember you cancel something out. So I'm going to start with 5 of my given units. Let's say it's grams. If I have grams on top, I would have to put the unit of grams on the bottom. And then I convert that to whatever I want, to whatever the desired units are. But I have now canceled out those starting units in my problem, so I would not have that starting unit anymore as my answer. I would now have the desired units. So we're going to work through these problems. You can try them. You can try the setup on your own, but we're going to work through these 8 problems in class, and then I'm going to turn you loose to do more practice problems. There is an Educreations video on dimensional analysis. You can watch that if you want to in the chemistry folder. But be prepared to work through these 8 problems that we are going to go through in class. And I'm going to skip these problems because they actually go with objective number 8. So problem solving practice, we'll do this in class. There are some websites that we are going to go to in class, so you don't need to worry about anything else.